When you're asking for the equation of a line tangent to a function at a specific point, it helps to think of a picture if you can visualize the graph. Now, hopefully you can understand this graph right here is a parabola. So if we made a quick little sketch, very quick sketch, what you would have is you have a parabola that might look something like this. Okay. And then it's saying at x equals 2, so say this is 1, 2. So at x equals 2, it's saying, okay, there is a tangent line right there. That is the tangent line of the graph right there, which is actually not the best drawn. It might be a little steeper, but it's the tangent line. Let's say that's the tangent line. And so what it's saying is, what's the equation? Y equals mx plus b, or this form, point slope. A lot of people are more familiar with this, but we're actually going to be using point slope formula. So we're trying to find the equation of this line right here, the tangent line at x equals 2 of a parabola. Now you can find a tangent line at any point. I can find a parabola. I mean a tangent line here, I can find it here, just equations of a tangent line anywhere. In order to find that equation, that red line right there, what I need is I need a slope and a coordinate. Alright, so we need a slope and a coordinate in order to find that tangent line. So let's do that. We're going to use this equation though. Instead of y equals mx plus b, which is also very reasonable, let's use this one. So we first need to find a coordinate xy and a slope. Alright, so let's find the coordinate. I know x equals 2, so to find the y value or the output, we plug 2 into the function. So I'm going to first do f of x equals 3x squared minus 5, and I'm going to plug in 2. So I'm going to find f of 2. This will give me the coordinate. So what is f of 2 going to equal? Well, f of 2 is going to be 3 times 4 minus 5, which that means that f of 2 looks like it's going to be 12 minus 5, which would be 7. So I have a coordinate of 2, 7. That's x, that's y. X and y, my point slope formula. Cool, I got my coordinate at this point right here. Again, this graph is not exactly the graph, it's just a sketch of what it possibly could look like. Alright, now I need my slope. Now I need my slope where? Well, I need my slope at that point. So to find my slope at a point, I need to derive this, and I'm going to have to plug the 2 in to find the slope there. So let's find the derivative of this function. So derivative f prime x, the derivative of 3x squared is going to be 3, bring the 2 out front, so 2 times 3 is 6, x, drop that by 1, so I don't need to put 1, because 2 minus 1 is 1, and that's good. The derivative of negative 5 is 0, so that's my derivative. Okay, and I want to find the slope where? At 2. So let's find the slope at 2. So we're going to find the slope at 2, and put 2 in for x, that would be 6 times 2. So what is my slope at 2? My slope at 2 is 12. So guess what? My slope at 2 is 12, so m equals 12. So I have my m, my x and y. Could I plug it into this and have an equation of a tangent line? I now have, okay, y minus y, which is 7, equals m, which is 12, times x minus x, which is 2. And that is the equation of a tangent line for this equation through this point. You could rewrite this in this form right here, and we can rewrite it if we distribute the 2. Okay, it's going to be 12x. Distribute this to be negative 12. Add the 7 over. So we have through the 12, you get negative 24. And when you add the 7 over, what would that be? It would be negative 17. That would be the equation in slope intercept form. This is the equation in point slope form. Okay, now again, equations of tangent lines are important because they give you an exact equation for that little segment, and those segments are nice to draw. If you use a graphing calculator and graph this and graphed this, you would get a perfect tangent line picture, nice and pretty. So let's recap. We first want to find the coordinate at this. There's our coordinate. We then want to find the slope at 2, so we derive it, plug in 2, and we put both those into point slope form to get the equation, which you can change to slope intercept form. Good luck with tangent lines. They're really important.